a living force in constant motion, powerful beyond measure, endless beyond sight, alive in ways that humanity is still struggling to fully understand. Stretching between continents and touching the shores of dozens of nations, the Atlantic is far more than a body of water on a map. It is a massive, interconnected system of currents, storms, pressure, and energy that shapes weather, influences climate, and impacts life across the planet. Beneath its surface lies a world driven by movement, a world where calm horizons can transform into chaos without warning. This is not simply an ocean. It is motion without pause, pressure without mercy, history written in waves, storms, and shipwrecks. Welcome to Unseen Abyss World, where we move beyond coastlines, beyond familiar waters, and beyond the limits of what feels safe. Here, we explore the most extreme and mysterious environments on Earth, uncovering the hidden forces that shape our planet in silence beneath the surface. Today, our journey takes us deep into the heart of the Atlantic Ocean, one of the most influential and dangerous oceans on Earth. An ocean that has connected civilizations for centuries while simultaneously destroying countless lives that attempted to cross it. From ancient voyages and trade routes to modern shipping lanes and scientific expeditions, the Atlantic has always stood as both a pathway and a barrier between worlds. At the surface, enormous currents move like invisible rivers across the ocean basin. Some carry warmth across continents, helping regulate temperatures and weather patterns far beyond the sea itself. Others fuel violent storms capable of unleashing enormous waves and hurricane-force winds across thousands of kilometers. The Atlantic does not remain still for long. Every current, every tide, and every shift in temperature becomes part of a larger system, constantly reshaping the world around it. But beneath those restless waters lies something even more extreme. As sunlight fades and depth increases, the Atlantic transforms into an environment ruled by darkness and immense pressure. Temperatures plunge, visibility disappears. The deeper the descent, the more hostile the ocean becomes. Yet, even here, life continues to survive in extraordinary ways. Creatures adapted to crushing pressure drift through the blackness below. Some produce their own light in a world untouched by the sun. Others rely on stealth, sensitivity, and patience to survive in an ecosystem where energy is scarce and every movement matters. In these depths, survival depends not on strength alone, but on adaptation to one of the harshest environments on Earth. The Atlantic is also an ocean of storms. Some of the most destructive weather systems ever recorded have formed above these waters. Hurricanes gather strength across its warm surface before crashing into coastlines with devastating force. Waves rise like moving walls. Winds tear across open water with terrifying speed. Even the largest ships can become vulnerable when the Atlantic reveals its full power. And scattered across the ocean floor are reminders of that power: countless wrecks lost to storms, navigation errors, war, or the unforgiving conditions of the sea itself. Beneath the Atlantic rests a hidden archive of human history: forgotten vessels, lost cargo, and untold stories preserved in darkness for decades, sometimes centuries. This is an ocean that never truly rests, an ocean that challenges explorers, tests technology, and reminds humanity how small we remain against the forces of nature. So join us as we journey across the Atlantic Ocean, through its storms, its depths, and its mysteries. Together, we will explore the hidden systems, extraordinary life, and immense forces that make the Atlantic one of the most powerful and unforgiving seas on Earth. The Atlantic Ocean is far more than a vast body of water separating continents. It is one of the most powerful natural systems on Earth, a restless force that has shaped climates, coastlines, civilizations, and human history for centuries. Stretching between the Americas to the west and Europe and Africa to the east, the Atlantic covers more than 106 million square kilometers, making it the second largest ocean on the planet. But its influence extends far beyond its size. From the icy Arctic in the north to the storm-driven waters near Antarctica in the south, the Atlantic connects entire hemispheres through weather, heat, movement, and life itself. Unlike land, the Atlantic is never truly still. Beneath its surface, enormous currents move continuously across thousands of kilometers, transporting heat, nutrients, and energy around the globe. Among them, the Gulf Stream stands as one of the most important ocean currents on Earth. Carrying warm tropical water northward, it helps regulate temperatures across North America and Europe, shaping weather systems and seasonal climates far beyond the ocean itself. Without these currents, entire regions would experience dramatically different climates. Winters across Europe would become far colder, ecosystems would shift, and weather patterns across continents would change. But the same forces that maintain balance can also create destruction. The Atlantic is one of the most violent oceans on Earth. Warm tropical waters collide with cold northern air masses, generating powerful storms capable of reshaping coastlines and devastating entire regions. Many of the world's strongest hurricanes develop in the Atlantic or gain strength from its warm waters before reaching land. Some storms grow into enormous rotating systems, visible from space spirals of cloud, wind, and energy stretching across vast distances. Further north, massive extratropical storms batter coastlines with relentless waves and hurricane-force winds. For centuries, sailors feared the Atlantic for its unpredictability. Even today, despite modern forecasting technology, the ocean remains dangerous and impossible to fully control. It moves according to forces far older and more powerful than civilization itself. Yet beneath the surface, the Atlantic becomes even more extraordinary. The ocean floor is not flat or empty. It is a hidden landscape of volcanic ridges, deep trenches, underwater mountains, and vast plains stretching across the darkness below. The average depth of the Atlantic reaches around 3,600 meters, but in some regions, the seafloor plunges beyond 8,000 meters into near total darkness. At these depths, sunlight disappears completely, temperatures approach freezing, and pressure becomes almost unimaginable. Running through the center of the Atlantic lies one of Earth's greatest geological structures, the Mid-Atlantic Ridge. Stretching more than 16,000 kilometers from north to south, this underwater mountain chain marks the boundary where tectonic plates slowly pull apart. Deep beneath the ocean, molten rock rises from Earth's interior, creating new seafloor in a process that has continued for millions of years. The Atlantic itself is still expanding, though only by a few centimeters each year, a reminder that the planet beneath us is constantly changing. Even in the extreme darkness of the deep ocean, life continues. Many organisms survive here through extraordinary adaptation. Some creatures produce their own light through bioluminescence, creating flashes of blue and green in the black water. Others survive with slow metabolisms and highly specialized bodies, designed for crushing pressure and limited food. Near hydrothermal vents along the Mid-Atlantic Ridge, entire ecosystems thrive around superheated mineral-rich water erupting from the seafloor. In these isolated regions, life exists without sunlight at all, relying instead on chemical energy rising from deep within the Earth. Closer to the surface, the Atlantic supports one of the most complex marine ecosystems on the planet. Tiny plankton drifting through the water form the base of an enormous food web, supporting fish, seabirds, whales, sharks, and countless other species. Seasonal blooms of microscopic life fuel migrations across entire oceans as animals travel thousands of kilometers following currents, temperatures, and prey. Everything in the Atlantic is connected through movement. Fish migrate through changing currents. Sea turtles cross entire ocean basins guided by instinct and Earth's magnetic field. Whales travel immense distances between feeding and breeding grounds, navigating one of the harshest environments on Earth. Even small changes in temperature or ocean chemistry can affect ecosystems across vast regions. The Atlantic is also deeply tied to human history. For centuries, it served as one of the world's primary routes for exploration, migration, trade, and conflict. Empires expanded across its waters. Explorers crossed it, searching for new lands and trade routes. Merchant ships transported resources, cultures, languages, and technologies between continents, helping shape the modern world. But the Atlantic also witnessed war, slavery, storms, and disaster. Beneath its surface rests a silent archive of human ambition and tragedy. Thousands of shipwrecks lie scattered across the seafloor, from ancient wooden vessels to modern steel ships lost during storms or war. Some remain remarkably preserved in the cold darkness for centuries. Each wreck tells a story of exploration, survival, or loss. Even today, the Atlantic remains essential to global civilization. Major shipping routes cross its waters every day, while undersea communication cables carry enormous amounts of the world's internet and financial data between continents. Scientists also study the Atlantic closely because its changing temperatures and circulation patterns play a major role in Earth's climate system. Small shifts within the ocean can influence weather, sea levels, marine ecosystems, and climate stability across the globe. Yet despite centuries of exploration, much of the Atlantic remains unknown. Large areas of the deep ocean have never been fully mapped. New species continue to be discovered, and many of the Atlantic's processes are still only partially understood. The deeper humanity looks into the Atlantic, the more it reveals how little we truly know about the world beneath the waves. The Atlantic Ocean does not offer peace or permanence. It offers motion, pressure, uncertainty, and power. Between continents and climates, between history and geology, it remains one of the most dynamic environments on Earth, a living system shaped by forces far beyond human control. This is the Atlantic, an ocean of storms and currents, of darkness and depth, of exploration, survival, and constant movement, essential to the planet, endlessly changing, and never truly at rest. How did humanity first realize that an immense ocean stretched far beyond the western horizon? And what gave early explorers the courage to believe that this unknown sea could be crossed rather than feared? Long before the Atlantic Ocean was fully understood, it existed in human imagination as a mysterious boundary, a vast and uncertain frontier where the familiar world seemed to end. To the ancient civilizations of the Mediterranean, the waters beyond the Strait of Gibraltar were not simply another sea. They represented the edge of existence itself. Beyond those narrow passages lay an ocean believed to be endless, violent, and unknowable, a place where storms swallowed ships, and where no clear path home could be guaranteed. For centuries, the Atlantic remained more myth than reality. Ancient maps often faded into emptiness beyond the western horizon, filled with legends of sea monsters, eternal darkness, and waters impossible to survive. The ocean inspired both fascination and fear, because no civilization truly understood how far it stretched or what might exist beyond it. Yet humanity's understanding of the Atlantic did not emerge from a single moment of discovery. It developed gradually, shaped by generations of sailors willing to venture farther from safety than those before them. Every expedition pushed the known world slightly outward. Among the earliest were the Phoenicians, skilled mariners whose ships traveled far beyond the familiar Mediterranean coastline. Guided only by stars, seasonal winds, and knowledge of coastal currents, they navigated waters that many others considered unreachable. Their voyages proved something important. The Atlantic was dangerous, but it was not an immediate death sentence. The sea could be entered, crossed in parts, and survived. Over time, confidence slowly replaced superstition. Sailors learned to recognize repeating wind systems and predictable ocean movements. They discovered that the sea behaved according to patterns rather than myths. Even so, the Atlantic still appeared unimaginably vast, and much of it remained hidden beyond the limits of exploration. Centuries later, another wave of explorers expanded humanity's understanding even further. Norse seafarers crossed the cold and unforgiving North Atlantic, navigating through storms, icy waters, and dense fog. Their journeys carried them to Iceland, Greenland, and eventually the shores of North America long before most of Europe knew such lands existed. These voyages demonstrated that enormous territories lay beyond the Western Ocean, and that the Atlantic connected distant worlds rather than separating them completely. Still, the true scale of the Atlantic remained uncertain. Large portions of the ocean were unmapped, and many crossings depended on instinct, luck, and courage as much as knowledge. Ships disappeared without explanation. Sudden storms could erase entire expeditions. The ocean continued to command respect because it remained larger and more powerful than human understanding. Everything began to change during the 15th century age of exploration. Advances in navigation, shipbuilding, and astronomy allowed European explorers to travel farther into open water than ever before. Mariners gradually learned to work with the Atlantic rather than fight against it. They observed recurring trade winds, powerful ocean currents, and seasonal routes that could carry ships across enormous distances. The Atlantic was no longer viewed simply as a terrifying void at the edge of civilization. It became a navigable system, a moving network of winds and currents, linking continents together. Voyages that once seemed impossible became repeatable. Explorers crossed from Europe to Africa to the Americas and back again with increasing confidence. As crossings became more frequent, knowledge replaced fear. Coastlines were carefully charted. Distances were measured with growing accuracy. Ocean currents were studied and remembered. What had once been an unknown wilderness slowly transformed into one of the world's most important pathways of exploration, trade, and cultural exchange. The Atlantic Ocean did not lose its danger. Storms, isolation, and immense distances continued to challenge every voyage. But humanity's perception of the ocean had fundamentally changed. The Atlantic was no longer defined by myths of the world's end. It was defined by experience by the countless sailors, explorers, and navigators who crossed its waters again and again, turning uncertainty into understanding. In the end, humanity did not discover the Atlantic in a single dramatic moment. The ocean revealed itself slowly, voyage after voyage, as courage expanded the boundaries of the known world. The Atlantic Ocean has earned its reputation as one of the most dangerous oceans on Earth, not because of a single force, but because every force within it is constantly in motion. Nothing here remains stable for long. The Atlantic is an ocean defined by movement, an immense system of shifting winds, powerful currents, rising pressure zones, and restless weather patterns that interact across thousands of kilometers without pause. In this environment, calm is temporary, and stability is often an illusion. Unlike smaller or more enclosed bodies of water, the Atlantic operates on a massive planetary scale. It stretches between continents, connecting the polar north to the warm tropics, and every region influences another. Cold Arctic air descends from the north, while warm tropical moisture rises from the south. Wind systems circle endlessly across open water. Currents carry heat across entire oceans. Together, these forces create one of the most energetic marine environments on Earth. The Atlantic surface can appear calm and endless under clear skies, but beneath that appearance lies constant instability. Conditions can change with frightening speed. A quiet horizon can darken within hours. Winds strengthen, pressure falls, waves begin to build. What was once navigable water can rapidly transform into a violent and chaotic sea, capable of overwhelming even experienced crews. This danger begins with weather. The Atlantic is one of the primary birthplaces of powerful storm systems. In tropical regions, hurricanes form above warm ocean waters where heat fuels enormous rotating systems of wind and rain. These storms gather strength as they move westward across the Atlantic, feeding on warm surface temperatures and expanding into massive structures visible even from space. Entire coastlines can fall under their influence. Winds can exceed devastating speeds, while waves grow high enough to engulf vessels and flood coastal regions. Farther north, another form of danger dominates. During autumn and winter, the North Atlantic becomes a battleground of contrasting air masses. Cold polar air collides with warmer southern systems, generating massive extratropical storms that can cover enormous sections of the ocean at once. These storms are not always as famous as hurricanes, yet many are equally destructive. They generate towering swells, freezing winds, heavy rain, dense fog, and violent turbulence across shipping routes that have been used for centuries. In the Atlantic, storms rarely exist in isolation. Wave systems from distant weather events travel thousands of kilometers across open water. A ship may encounter dangerous seas even under clear skies because the energy of a storm continues moving long after the storm itself has disappeared beyond the horizon. This ability for danger to travel across vast distances makes the Atlantic especially unpredictable. Waves here can become enormous. During severe storms, walls of water can rise 20 to 30 meters high, powerful enough to damage steel structures and destabilize massive ships. Some waves form unexpectedly when multiple swell systems intersect, creating steep and chaotic seas. Sailors have described these moments as encounters with moving mountains, water rising from every direction at once, leaving almost no room for control. But the Atlantic's danger is not limited to what happens above the surface. Beneath the ocean lies another world of invisible forces shaping everything above it. The Atlantic is driven by powerful current systems that move vast amounts of water across the planet. Among the most influential is the Gulf Stream, a fast-moving current carrying warm tropical water northward along the eastern coast of North America before crossing toward Europe. This current plays a critical role in regulating global climate, but it also creates highly unstable marine conditions. Where warm and cold waters meet, the atmosphere becomes unpredictable. Fog forms rapidly, wind patterns shift, sudden storms intensify. At sea level, the interaction of opposing currents causes waves to steepen and break irregularly. Swells intersect from different directions, making navigation difficult even for modern vessels equipped with advanced systems. In certain regions, these currents become especially dangerous. Areas where underwater terrain forces water upward can create violent turbulence beneath the surface. Powerful eddies and rotating water masses form without warning. Even experienced crews can struggle to predict how the ocean will behave in these zones, because much of the Atlantic's movement remains invisible to the human eye. Depth adds another layer of danger. Large sections of the Atlantic plunge rapidly into deep ocean basins, where the sea floor lies 3,000 to 5,000 meters below the surface. Beyond the continental shelves, the ocean becomes a vast abyss of pressure, darkness, and cold. In these regions, the environment is unforgiving. Rescue operations become extraordinarily difficult. Communication is limited. Weather conditions can delay assistance for days. If an accident occurs far from land, survival often depends entirely on immediate response. The cold waters of the North Atlantic are particularly lethal. Human body temperature can drop dangerously within minutes, even if a person survives the initial impact of the sea. History has repeatedly shown that in these waters, distance and temperature can become just as deadly as storms themselves. And despite advances in modern technology, the Atlantic still resists complete control. Satellites, forecasting systems, radar, and navigation tools have improved maritime safety dramatically, yet the ocean continues to produce conditions that challenge human prediction. Pressure systems evolve unexpectedly. Storm tracks shift. Mechanical failures occur in environments where even small errors can escalate rapidly into catastrophe. The Atlantic is also an ocean of narrow passages and concentrated activity. Major shipping lanes cross its waters every day, linking continents through routes essential to global trade. Enormous cargo vessels, fishing fleets, passenger ships, and military operations move continuously across these corridors. But many of these routes pass through confined or hazardous regions where natural forces intensify risk. Straits, shallow continental shelves, submerged ridges, and coastal fog zones create dangerous intersections between human activity and environmental instability. In some regions, strong tides and opposing currents generate rough seas that shift constantly. Visibility may disappear within minutes under dense fog or heavy storms. Navigation errors become more likely, especially in heavily traveled waters. Many of the world's most infamous shipwreck zones are found within the Atlantic. Some wrecks resulted from violent storms, others from hidden underwater terrain, powerful currents, mechanical failures, or simple human miscalculation amplified by unforgiving conditions. Beneath the surface lies a vast record of maritime history, evidence of how difficult this ocean has always been to master. Yet, what makes the Atlantic truly dangerous is not only the violence of its storms or the depth of its waters. It is the ocean's dual nature. The Atlantic is both a pathway and a threat. It connects continents, carries commerce, regulates climate, and supports exploration across the globe. Entire civilizations developed around its trade routes and coastlines. The same currents that make navigation possible also shape weather systems that can destroy ships. The same winds that once carried explorers across oceans can rapidly become forces of devastation. This constant balance between opportunity and danger defines the Atlantic more than anything else. It rewards precision, preparation, and respect, but it punishes hesitation, overconfidence, and complacency. Unlike environments that appear dangerous immediately, the Atlantic often hides its power beneath moments of deceptive calm. Its surface can seem peaceful, while immense energy builds invisibly across distant horizons. To survive here has always required understanding forces that cannot fully be seen, only sensed, studied, and respected. The Atlantic Ocean does not seek destruction. It follows the laws of wind, temperature, gravity, and motion with relentless consistency. But because those forces never truly stop, the Atlantic never truly rests. Every storm, every current, every wave is part of a system constantly reshaping itself across one of the largest oceans on Earth. This is the Atlantic as a dangerous ocean. Not because it is evil or hostile, but because it is endlessly active, an ocean where power is constant, danger is always moving, and nature never slows down. What happens when light no longer reaches the sea? What exists beneath the shifting storms and endless horizons of the Atlantic Ocean, far below the surface world humans know so well? From above, the Atlantic appears alive with motion. Waves rise and collapse across thousands of kilometers. Storm systems sweep across open water. Powerful currents carry heat between continents, shaping climates and influencing life on Earth itself. Ships cross its surface every day. Satellites observe its movements from space, and coastlines around the ocean pulse with human activity. But below the surface, the Atlantic transforms into something entirely different. Just a short distance downward, sunlight begins to disappear. The bright blue tones of shallow water slowly fade into darker shades of gray. Red vanishes first, then orange and yellow, until eventually almost all color is erased. The ocean becomes colder, heavier, and increasingly unfamiliar. At depths of around 200 meters, the sun's influence weakens dramatically. Light becomes faint and scattered. Beyond this zone, the Atlantic enters a realm where darkness dominates nearly everything. By 1,000 meters, sunlight is almost completely gone. Here, The ocean no longer responds to weather or the changing sky above. Storms that churn the surface become meaningless in the deep. Day and night no longer exist. Time itself seems to slow in the stillness. The environment is controlled by entirely different forces: pressure, cold, and isolation. Temperatures hover only a few degrees above freezing. Every movement requires energy in a place where food is scarce and survival is never guaranteed. Above all, pressure defines existence here. With every descent, the weight of the ocean increases. At extreme depths, the water presses with forces hundreds of times greater than the pressure humans experience on land. For most forms of life from the surface world, survival here would be impossible. Yet the Atlantic depths are not empty. Far beneath the waves lie enormous abyssal plains, some of the largest and most isolated landscapes on Earth. These vast underwater basins stretch for thousands of kilometers across the seafloor, resting between 3,000 and 5,000 meters below the surface. In many places, the terrain appears almost endless, flat and silent beneath complete darkness. Very little disturbs these deep regions. There are no forests, no sunlight, no changing seasons. The seafloor receives only a slow rain of organic material, drifting down from waters far above tiny fragments of dead plankton, microscopic debris, and the remains of creatures from the upper ocean. Marine scientists sometimes call it marine snow, though there is nothing gentle about the struggle it supports. Every particle matters. Life in the abyss survives through patience and efficiency. Organisms move slowly to conserve energy. Some species may go long periods without feeding. Others have evolved enormous mouths or expandable stomachs, allowing them to consume almost anything they encounter because another opportunity may not come for weeks or even months. In this darkness, survival depends not on speed or strength, but on adaptation. Some creatures possess transparent bodies that nearly disappear in the black water. Others generate their own light through bioluminescence, cold flashes of blue or green illumination used to attract prey, communicate, or confuse predators. Tiny lights drift through the darkness like moving stars in an underwater night sky. Many deep-sea fish appear almost alien to human eyes. Oversized jaws, needle-like teeth, massive eyes adapted for faint traces of light, or in some cases, no eyes at all. Every feature has been shaped by one of the harshest environments on the planet. And still, much of this world remains unseen. Large portions of the Atlantic seafloor have never been fully mapped in detail. Despite modern technology, humanity knows more about the surface of some distant planets than parts of Earth's deep ocean. Vast regions remain unexplored simply because reaching them is extraordinarily difficult. Descending into the deep Atlantic is one of the greatest engineering challenges humans face. The deeper a vehicle travels, the more dangerous the ocean becomes. At depths beyond 4,000 meters, pressure becomes crushing. Even thick steel and advanced materials are pushed close to their limits. A single weakness, a tiny structural failure, could lead to catastrophic collapse within seconds. Unlike mountains or deserts on land, the deep ocean does not forgive mistakes. Submersibles designed for extreme depths must survive conditions unlike almost anywhere else on Earth. Every cable, seal, and component is tested against forces difficult to imagine. Communication with the surface becomes limited. Rescue is often impossible. In the deepest parts of the Atlantic, humans enter an environment where nature completely dominates technology. Yet, even in these hostile depths, the Atlantic continues to reveal extraordinary discoveries. Cutting directly through the center of the ocean lies one of the largest geological structures on Earth, the Mid-Atlantic Ridge. Stretching more than 16,000 kilometers from north to south, this immense underwater mountain chain divides tectonic plates that slowly pull apart over millions of years. Deep beneath the seafloor, heat rises from Earth's interior. Along fractures in the ridge, superheated water erupts through hydrothermal vents, carrying dissolved minerals into the surrounding ocean. In the freezing darkness of the deep Atlantic, these vents create one of the most remarkable ecosystems ever discovered. Here, life exists without sunlight. Instead of depending on photosynthesis like plants and surface ecosystems, organisms around hydrothermal vents survive through chemosynthesis using chemical energy released from the Earth itself. Entire biological communities thrive around these vents. Giant tube worms, unusual crustaceans, specialized bacteria, and deep-sea creatures found nowhere else on the planet. The discovery of these ecosystems changed scientific understanding of life itself. For centuries, humans believed sunlight was essential for complex ecosystems to exist. But deep beneath the Atlantic, life found another way. These vent systems are temporary and unstable. Some remain active for decades, others for centuries, before eventually cooling and dying. Yet, while they last, they become islands of life surrounded by immense darkness. Elsewhere in the Atlantic depths, strange predators drift through black water with almost invisible movements. Giant squid patrol deeper layers rarely witnessed by humans. Siphonophores stretch through the darkness like living chains of light. Delicate jellyfish pulse silently through cold currents older than human civilization. Some species discovered in the deep Atlantic have only been observed once. Others remain unnamed because scientists still know so little about them. Every expedition into the abyss has the potential to uncover entirely new forms of life. The deeper researchers explore, the more the Atlantic challenges assumptions about biology, adaptation, and survival. But the deep ocean is not simply mysterious because it is dark. It is mysterious because it operates on scales difficult for humans to truly understand. Distances are immense. Pressure is constant. Movement is slow and deliberate. In many areas, the environment changes so gradually that geological transformations unfold over thousands or millions of years. Sediments settle grain by grain across ancient seafloors, untouched by sunlight for entire ages of Earth's history. Down here, the Atlantic feels less like a place on Earth and more like another world entirely. And despite centuries of exploration, humanity has only begun to understand it. Below the surface, the Atlantic is not violent in the way surface storms are violent. It does not roar with crashing waves or hurricane winds. Its power is quieter, deeper, and far more relentless. It is a world of immense silence, a world where darkness stretches across entire continents beneath the sea, a place where pressure replaces motion, where survival depends on extreme adaptation, and where life persists against conditions once thought impossible. Far below the reach of sunlight, the Atlantic reveals its true scale not simply as an ocean between continents, but as one of the largest unexplored environments on Earth, unmapped, unseen, and profoundly unknown.